So currently, what we're looking at is a graphene sheet. Graphene is extremely flexible, lightweight, 200 times stronger than steel, 40 times stronger than diamond, and could be one of the easily produced nanotechnologies of the future. Graphene is going to be the pinnacle of nanotechnology research in the future. And it will revolutionize how you listen to your phone, drive your car, and do so many other things in about 10 years, 15 years, 20 years. Between 10 and 20 years from now, graphene will be finding its way into phones, televisions, cars, computer chips. Everything will be changing to graphene within 10 to 20 years from now. And not only that, but it will revolutionize green energy to the point that we've never anticipated before. And it will even allow for science fiction to become reality. And I'll explain how. Right now, I will start with the science fiction first. The most interesting stuff going to the less interesting stuff. I don't like keeping my fans waiting. Okay, so graphene, basically, as I said, is a carbon nano tube made from graphene, which is what graphite is actually made from. But did you know that you could actually build planetary shields from graphene? And it's very easy. Take an example, Venus, the hottest planet in the solar system, made entirely of carbon dioxide, almost entirely. 96% of Venus is made of carbon dioxide. That's even more than coal, which is usually 90% carbon dioxide. Basically, Venus is basically all carbon dioxide. If you go to the surface of Venus, 90 atmospheres of pressure. All of it almost carbon dioxide. Almost all of it. 4% for nitrogen. And just imagine, you take 12 graphene nanotubes and send it down to Venus and have robots that are, graphene, made of graphene metal or graphene or some other nanocomposite material that's indestructible, and basically try to implant it in the ground, and then once the nanotubes are set up, going up to 300 kilometers into the into space, 300 kilometers, about 100 miles or so, a little over 100 miles, or just beyond the atmosphere, maybe 400 miles into the atmosphere, have Venus enshrouded in graphene in a maybe 3 micron thick graphene sheet that will envelop the whole planet, that will block all UV radiation. So it's not just graphene, also maybe made of another composite material that will block radiation. So no light gets into Venus. Block all incoming light from reaching Venus for at least 5 to 10 years. Hopefully by then, the atmosphere will begin to cool enough that not only will Venus become habitable, but maybe wait another 5 or 10 years, the atmosphere will become thinner and thinner and thinner, to the point that almost all of the carbon dioxide in Venus have precipitated out. Venus is now an ice planet, and then you take some of the carbon dioxide, transfer it over to Mars, take the rest of the carbon dioxide, send it into space, or build more graphene from it. I mean, there's going to be so much carbon dioxide in Venus, Venus could essentially become a plant for producing graphene. Producing other... Venus will be a nanotechnology plant. Because now you have so much carbon dioxide in Venus, you could basically set up colonies in Venus, or robot colonies, where they will produce our carbon nanotechnology. All of our composite materials, all of our graphene will be produced in Venus. No need for industry on Earth. Earth, is meant to be a natural living planet. And once you've gotten enough carbon dioxide out of Venus, melt the rest of the carbon dioxide, which will probably take thousands of years to just go through all of that carbon dioxide, and turn Venus into a habitable planet. Mars, on the other hand, could be turned into a habitable planet within a few hundred years, maybe even a few decades. Sends truckloads of all this frozen carbon dioxide to Mars, send it to the equator in the summer, melt the carbon dioxide, let it go in the atmosphere, and then the greenhouse effect will take place. And Mars will become closer to Earth with maybe temperatures of 50 to 60 degrees within 30 or 40 years. maybe 100 years. Take a little longer, so probably take a couple hundred years. But Mars will eventually have a thickness about Earth, temperature probably of 50, 60 degrees. Then introduce water from some of the ice worlds, like comets, and then crash comets onto Mars, or better yet, send ice to Venus, to Mars, have it melt in the equator, and have Mars become a water-rich planet, or have water in it, and then introduce vegetation to Venus, oxygen, oxygen to Mars, and have the water from the surface to flow to the from the subsurface to flow to the surface, and it will not evaporate. It will not evaporate immediately because there's now pressure. And not only that, but this is not so far-fetched. Scientists have talked about this actually. And here's how what's going on with graphene. This is the future predicted price of graphene as of 2013, and it's becoming very cheap to produce. And just recently, scientists have now said they produce graphene 100 times cheaper than ever before. So, in fact, that is in fact true, because the researchers. So now graphene will likely become the material of the future. It's now the material that we all need. So, basically, you could have a you could eventually do it with graphene. Yeah, definitely. But actually, I would not invest in it right now like I've been telling people to. I'm not into investing. This is not what this is about. This is not a seminar of any kind. This is what will happen in the future. Problem with graphene is that now that you have an explosion of research, right now graphene is the most expensive. You gotta wait for the prices to bottom out, then invest, and then prices will go back up again. That's gonna take years. Yeah. You can do it. So yes, we can do it. Not about the investing part, but we can actually save the world with graphene. Graphene could also be made from coal. You could make it from existing carbon dioxide on Earth. You could do it from carbon capture and storage. You could actually capture carbon dioxide from power plants, convert that the carbon dioxide into graphene using nanotechnology. Because graphene also is self-healing. It could actually use existing carbon to repair itself. Graphene is also self-repairing. Because it's nanotechnology. It is self-repairing as well. You see? It knits itself back together. And this is, in fact, it's not, it's not science fiction. It's not intelligence. It's just, well, how the world works. So it's like you have a skin cut. Or, it's, another carbon atom will, float to the missing atom, and it will basically stick. And that's how it works. It's just simply like that. It's not, old nanotechnology. It's not like intelligent. It's not doing it by. So yes, this is in fact realistic. Because graphene can self-heal. That's very, very important for what we need to do. Great. Ultra slippery coating for glass. So this is what graphene actually looks like through a telescope, but this is what it actually looks up way close up. But terraforming a Venus could be, done that. Wow, that's a lot of hydrogen. I would take introduction of hydrogen. Mine is more space-based. Yeah, this is the one. Solar shades. This is my theory. This is the one I suggested, using graphene. No. You could use that in graphene. My theory is not using shields. Huh. My theory is different. My theory is a little different. Just coat the whole planet in the shield. One giant shield. Basically, the entire planet is now going to be a giant mirror made from graphene. Or instead of mirror, it's more like it's going to absorb the heat and turn it into energy. It's going to absorb the heat and turn it into energy. But because Venus does not rotate, but I'll still recommend putting the whole planet in the shield, because solar radiation is being stripped away by the solar wind. So a lot of the Venetian atmosphere is being stripped away by the solar wind. So that will also prevent the loss of the atmospheric elements being stripped away. The shades panels. My theory is a little different. Yes. Actually, no, my theory is different. You basically have the nanotubes going up to 400, 500 kilometers into the space, and then coat the whole planet in the sheet. So not to make it too far out, and basically wastes a lot of elements. So basically, you could just coat it right around the planet. And once the planet cools down, you basically then harvest the carbon dioxide and use that frozen carbon dioxide to terraform other planets. That's my theory. That's just my theory. Then ship that frozen carbon dioxide over to, as I said, to Mars. It's my theory, and I think my theory should work out better than any others. Or it should work out, but there's probably still a lot of holes in my theory that need to be fixed. And I believe the people of NASA, we can do this. NASA, we can do this. Definitely do this. Probably take a few decades, maybe a century or so, but we can do it. Thank you for watching. Bye.